In this video, I will present an introduction of stacks. Stack is a data structure in which we can place items on the top of each other. And the important thing about the stack is that if you want to remove an item from the stack, then you must have to remove the elements on top of it first. Like here you can see an example. This is a stack of coins, this is a stack of trays. The items are being placed on top of each other. This is a stack of boxes and this is a stack of books. So what is the important feature about the stack is that it works like a last in first out data structure. It means that the element that have you inserted onto the stack, that have you more good term we use pushed, the last element that you have pushed will be the first element deleted out of the stack, or we can say popped out of the stack. Stack works like last in first out methodology. And for example, we want to remove this book, C++ programming. We want to remove this book out of the stack. Then we must have to remove first applied math book. It will be removed. Then we will have to remove world history book from the stack, and then we can remove this book from the stack. Means that in a stack only the top element can be removed at one time from the stack. We cannot remove any element that is in the in beneath of the top element. First we have to remove the top element of the stack. So it works in LIFO style. So let us see what is LIFO, what is last in first out structure. Let us see, we have these boxes, box A, box B, E, C and D, and initially these boxes are placed on the floor and we have empty stack. In stack, when we want to add an element to the stack, we use terminology push. Push means adding a new element to the stack. And like I have described earlier, only top element can be removed from the stack at one time. Similarly, when we want to add a new item to the stack, we can only add it to the top of the stack. We cannot add the element in the middle of the stack, in the bottom of the stack. We can only add element to the top of the stack. So adding or insertion of a new element to the top of the stack is known as push element to the stack. And when we remove a element from the top of the stack, we name this process as pop from the stack. And we have another variable known as top. This variable has the memory address of the top element of the stack. So let us see what is push and what is pop. So first of all, we have these 5 initial boxes and we have empty stack. In the next diagram, you can see that when we push a box A to the stack, we got one item in the stack, that is our top element. Okay, and only one element in the stack at the moment. Then we again push box B onto the stack. Now stack has 2 elements. A is below of the B. B is on the top of the stack. Then we again push another box C to the stack. Now our stack has 3 elements and C is on the top of the stack. Then we peek. And what is peek? Peek is mean getting the value on the top, from the top of the stack. What is placed on the top of the stack? We do not remove the element from the top of the stack in peek operation. We just get the value of the top element of the stack. So then we push box D. Now we have 4 elements in the stack, and we have box D on the top of the stack. Then we apply pop operation. Pop operation removes the top element from the stack and returns it. So it removes the top element D from the stack, and now C is the top element of the stack. So that is basically basic stack operations, and we will now discuss the basic stack ADT class in the next video.